Hi all, myself Sriram. Have been working on this connected cars vehicle solution. My solution was containing three features in addition to the basic version. As you can see, the first one was a chatbot feature where we wanted to implement a chatbot and to be more interactive and to give assistance to the owner. The second one was self-learning suggestions, which was based on deep learning and more of statistical data. And third one was face recognition feature. So, in addition to the basic version which includes the uh, everything such as vehicle health reports, anomaly detection, all those stuff. So, I have implemented this solution partially. I have implemented one feature actually in view of the time, the face recognition feature. So, let's not waste any more time and let's go into it. So as you can see, the connected vehicle approach, what does it say as per the architecture is that uh, once you have this IoT simulator, so the data will be captured and it will be passed on to different streams such as Kinesis and Lambda functions, and in turn it will be stored into DynamoDB tables. So this is a vast template, I can say. So you can download the template. I'll be providing actually uh, uh, in the attachments. So here is the template, connected vehicle solution template. This is a cloud formation template, which is basically once you deploy the cloud formation template, you will be able have deployed it. See here, TCC1, that is the template which I have deployed. So once if at all there are any errors, you have to change it, such as like region support, or minimal errors will be there, such as like CloudWatch logs. So all the stuff you have to correct, and then you have to deploy this template. So once this template is deployed, so various tables will be created and various functions. There are I'll tell you, for example, there will be three to four things. First one is in DynamoDB, there will be different tables which will be created, and in S3 there will be different buckets which will be created, so that if you can see here, the connected cars. Sorry, this is for simulator. Um, yeah, yeah, TCC. Yeah, I think this is the one. Connected cars, vehicle trip data, vehicle, everything. These all these things will be created by the template itself. And if you see here, in the DynamoDB tables, the TCC one, this is the prefix which I have added actually for the DynamoDB tables. It will contain all these ad tracking tables, which means for tracking the ads. DTC is for one second. Yeah, this is for um, detection of in case of any malfunctions or minor things for the car. Then health reports, as you can see, marketing tables and anomaly detection. So all these will be created actually by the template itself. Then once it is created, you have to go to AWS IoT Core, and you have to create a thing here. Manage, yeah, here you have to create one test car, or something like one car, a thing actually, which suppose. Then you have to go to yeah, test, and subscribe to a topic, and the topic should be the simulation topic here, which is given as simulation topic. So I'll show you how to do that simulation as well. uh, So this is related to connected cars. Basic version of the solution, which covers almost all the scenarios such as anomaly, health reports, trip data, everything. So I'll show you the simulation. For simulation, you there is another template which you have to deploy it in the IoT device simulator. So the template also have supplied here. So once you deploy the template uh, in the cloud formation, you can see that create template successful. Otherwise you may face minor issues. Depends on there will be like some tasks which are unattended in the logs. You have to clear those tasks. All such small things will be there. You have to correct them and you have to deploy them. So once it is deployed, you can see in the DynamoDB, see all these IoT sim device types, IoT sim, all these top 5 tables are created by simulator itself, such as it indicates different data actually. Say uh, this is my ID which I have created. This is like different device types. I have created three devices actually. I'll show it right now. This is different widgets for which we have created, and simulation metrics. For example, I have ran a simulation. So when is this device has got breakdown, and how many monthly runs, all the stuff will be there here. Even simulation settings, how many automotive simulations which I have run, something like that. If you see, once the simulation, at the time of creation of simulation itself, you should provide your admin ID as well as the email, password, all the stuff. So once it is done, within say 24 hours or so, you will be getting an email to the registered email ID saying this will be the particular link which you have to log in for simulation. So and they'll be providing a default password for which you have to reset um, after the first login. So if you see here, this is my simulation console where I have created three devices. For example, um, one second. So this one is um, these are the devices which I have created. There are like two vehicles and one is normal widget, add device kind of stuff. So if you see, one is still running, and I'll quickly show you the data. Don't mind, the mirror is showing me my images in the backside. So if you see here, this is the data which is still running actually. I think it goes for max of 10 to 15 minutes. That's it. I have started it around 10 minutes ago. So if you see here, this is the topic which under which the below data will be getting published. For example, timestamp, trip ID, VIN, name, latitude, longitude. So all these things can be customized as well. For the sake of time, I have given the default one, so it just took the default one and started simulation. So so this is the name of the topic which you have to give in the other parameter here. Yes, in the MQTT client, you have to subscribe to a topic. Here you have to mention the topic name and subscribe to a topic. Then it gets connected, and whatever the data, for example, is present there will be coming here directly to the tables. For example, if you see here, vehicle trip table. See, if you see the trip, no, third trip, it's uh, if you see that name of the VIN is the same as here, device simulator VIN, KAYL, KAYL. And if you the number of trips also, the date timestamp, if I'm not able to find one timestamp, but yeah, you can see here start time is 29th 11, which is today. So that's one. Then that's how the simulation works generally. So this is the basic feature and basic setup of how will you do a connected cars challenge. Um, I'll quickly move on to my um, additional feature, which is face recognition feature for the connected car challenge. The basic idea behind this face recognition feature was that if there is a possibility of uploading a picture from mobile, say if the owner has a mobile, and I mean we can use the face recognition as a security feature in the connected cars challenge. That was the proposed solution. It was now I have implemented the basic version in that, such as if you see, there is this is the deployment package which I have supplied here, and this will be the lambda function which I have coded it. uh, I haven't integrated with the mobile, but I have done the backend homework, such as I have put it with S3 bucket, so that if any picture has been uploaded into that particular S3 bucket, it triggers a lambda function, which in turn checks for the image in a particular bucket and that collection, and based on that it retrieves the details from a DynamoDB table and appropriately publishes a message. So I can show you the working version. um, if you see, okay, I have to change it. Okay. Okay, 1 second. I had no access to recognition from a different ID, so I had to do it on my personal ID. So yes, if you go to Lambda, okay, the function name which I have coded is TL1, and if you see the DynamoDB, I have coded few tables um, which contains minimal data just to show it actually that this can work. So this is a lambda trigger bucket where if I upload any image, it triggers the lambda function, and then it checks for whether the image is present in any of the collection or not. Mm, okay, so now I have disabled the trigger actually, so I will enable it again. While creating a lambda function, you just need to add the trigger S3 trigger here, and I have given my related accesses. I have created a role, this lambda role, and then I have given recognition full access and S3 full access to it. So now this is the trigger which I have enabled. The trigger on the this bucket 04 lambda trigger bucket. So save it. So once it is saved, So this is the function which I have created, which I have shown you already. Um, what it does is basically this one is add face index, where the owner will try to add at least three pictures of him, so that the machine learning algorithm will try to adapt his face to it, and so you can train the algorithm using the pictures. So the second one is search person. When you are passing a bucket and you're passing an object name and collection ID, so what it does is it goes to that bucket, and it checks for that particular object, and that object it takes as an input and searches for a face similar feature in the previous collection which we have added actually. So here we have we can even create the collection, or we can even list down the collections. I mean, what are the objects which are present in the collections. So all the stuff we can do. So this one is to get the details from the DynamoDB table. We are passing the table name and key value. The Here I have used the image ID, external image ID, as an attribute and as a key between both the Dynamo and recognition as a common key. So this is the main para where in case of an any item upload to S3 bucket, so that will be pulled up from here, and you'll be passed on, and you'll be calling the next one, and it searches that particular image. So I have disabled the add face index because I have already trained my model here, so I have disabled it, and we can enable later. It is also one more thing was it was taking more time when in case of add face index, so I have disabled it. So it's already my model is already trained on it, and so here the same the test image, and we'll be passing from S3 bucket. Then these the other parameters will be coming from the DynamoDB table. So then you'll be getting you can we'll be seeing this message soon. So let me upload an image quickly. um, Test 01. Okay, that's my image. Basically I am trying to upload. Okay, it's asking for confirmation. I upload. So once I upload this image, it triggers the lambda function. So you can't see anything here, but what we can do is we go to CloudWatch logs. Okay, okay. We go to CloudWatch logs. Okay, click on logs. Yes, my function is here TL1. Then you can see 29 22 11. Yes, this is the one. Okay, now you can see this is the bucket name I have printed for test and test 01. This is the output. You can see the output here. Welcome to MITR. Hello, Mr. Sriram. Weather is cold in India. Your Volkswagen Polo is in good condition. We are good to go. So this is the values which I have picked up from owner details. Uh, these are the couple of samples which I have given. It takes this as the key, and this is the location, this is the model name of the car, and name of the owner. So this is all the details. Please have a look and let me know in case of any questions. Thank you so much.